Welcome to the Parsons Healthy Materials Lab exhibition opening. Actually, it's not an exhibition opening. It is, in fact, our conversation today, and then we hope to have our exhibition opening next Tuesday, so stay tuned for that. The title of the exhibition is Regeneration of Flax, Linseed, Linen, Chive, and Oil. My name is Alison Mears. I'm an architect, associate professor, and director, co-founder of Healthy Materials Lab here in New York. For the last few years, HML has been investigating the harmful impacts of the building industry, an industry based on petrochemicals. We know that the largely unregulated synthetic chemicals used in common building products are harmful to us, particularly in use inside our homes. We've worked to identify healthier alternatives, but we're interested in identifying the truly healthy materials that would enable us to build regenerative, sustainable, long-lived structures that would not harm any of us. The long history of natural building and historic building practices holds some clues, and a handful of colleagues experimenting in hemp lime and in straw have provided us with the beginnings of a roadmap that could lead us to scale new plant and earth-based products. Enter flax, one of the most useful of all plants. Flax provides us with food, fiber, and chive, and like our old friend hemp, rebuilds architectural fields as part of an important movement to regenerate soils. When we work with the byproducts of plants, we have to work differently. We must know much more about agricultural processes, soil health, the impact of climate change on the health and yields of crops. And we need to innovate new processing techniques, new products, and new installation and performance characteristics. The real drivers of new flax production are textiles like linen, linseeds, and oil, the high-value industries. But these industries offer opportunities to be aligned with other industries like construction. In this exhibition, we exhibit 90 diverse objects, all derived from this one flax plant with hundreds of possible uses. At Healthy Materials Lab, we know it's possible to build homes that reduce toxics and carbon emissions. This is better for everyone and better for the planet. Where the truly healthy materials, like flax, that are part of the solution. This exhibition illustrates the range of innovative explorations that offer us these clues. Our design-led research lab was founded in New York and funded in New York in 2015. And our work and collaborations now span across the US and within the EU. We're architects, designers, educators, and a range of researchers. Our work is nurtured through interdisciplinary and collaborative approaches. Tonight, you'll see the outcome of one of these endeavors, the Regeneration of Flax exhibition, and this evening's panel of flax experts. It takes a mighty team, particularly on days like today, to bring a project like this to fruition. And we thank all members of HML's team for their tireless efforts. Special thanks to Jess up next for conceiving the project and leading up the exhibition, the installation, the conception, and the choice of the products included in the exhibition. Jess will introduce the exhibition and our guests who will share their work to advance the multiple uses of flax. Thanks, Jess.
Great. Thank you so much, Allison. For housekeeping today, please note that we will be recording this event. Viewers on Zoom are asked to ask questions in the Q&A, and please note that you will stay muted. I want to thank our sponsors, Forvo, Duracryl, and Tuscarora Mills, whose donations have helped make this event and our exhibition possible. Flax is a versatile natural bast fiber with significant environmental and economic advantages. Today, we discuss the challenges to scaling bio-based materials, the potential for a North American fiber flax industry, and the importance of preserving fibers whose stories have been intertwined with most of human history. In textile production today, 43 million tons of chemicals are used every year. And the textile industry is responsible for 1.2 billion tons of CO2 emissions, due in part to its dominance of synthetic fibers like polyester. We see the potential for scaling flax cultivation regionally and envision a future where natural fibers like flax surpass and replace the production and use of these synthetics. The Regeneration of Flax exhibition is at the Arnold and Sheila Aronson Galleries now through November the 12th, and we hope you'll be able to come and visit in person. Today, we're grateful to be joined by a panel of flax experts. Heidi Barr is the co-founder and CEO of the PA Flax Project, a cooperative dedicated to reimagining the flax for linen industry in Pennsylvania. For over a decade, she owned and operated Kitchen Garden Textiles, a Philadelphia-based life cycle brand working at the intersection of food and fabric. In 2020, with farmer Emma DeLong, Heidi took this understanding to the next level, and the PA Flax Project began. Joining us remotely since the 1990s, Alvin Ulrich has used public and private funding to carry out R&D work related to the flax straw, fiber, and shive with Violin Research, Inc., a company he founded in Saskatchewan, Canada, the major source location of oilseed flax in North America. His extensive experience growing, processing, grading, and finding end uses for both fiber and non-fiber portions of the flax plant have made him one of North America's leading linologists. Also joining us remotely, Marie Demacht, I hope I said that right, is a textile and sustainability manager at the Alliance for European Flax, Linen, and Hemp, formerly CELC. She's in charge of enhancing innovation in linen textiles, yarns, wovens, and knits, and supporting designers in sourcing them, thanks to the digital and physical material libraries, linendreamlab.com and Linen Dream Lab Paris. She coordinates life cycle data across the European flax and linen agro industry to highlight responsible practices of European flax fiber and masters of linen textiles to make reliable data through key databases. I'll now pass over to Heidi to tell us a bit more about her work with the PA Flax Project.
First of all, thank you, Jess, for putting this whole thing together. It's been really incredible to watch you from beginning to today to fruition. And I know a lot of people will visit in person as they can over the next few weeks. Yeah.
It's going to minimize here so we're in person.
Great.
Audience.
Thank you. So my name is Heidi Barr, and I'm the co-founder and CEO of the Pennsylvania Flax Project. My slide didn't want to advance. We're already having technical difficulty. Okay.
There you go. That should work.
Okay, great. Here I am in my happy place with my co-founder, farmer Emma DeLong, in a field of flax at her diversified vegetable farm, Mihai Farm in Pottstown, Pennsylvania. Emma and I met in 2020, and in the intervening years, we have been at a breakneck pace to reimagine the flax for linen industry in Pennsylvania. Pennsylvania Flax Project is now knowledgeable, connected, and poised to reestablish the fiber flax industry in Pennsylvania. And we're super excited to be here and be on this panel with other experts who are working in the field. We legally are formed as a cooperative in 2021. We've now had 4 successful growing seasons, and in January of this year, we received the USDA's Organic Market Development Grant for $1.68 million, and we are incredibly honored and lucky to have had our work recognized and uplifted by our government in this way, and hoping that it paves the way for others in the industry across North America to receive similar funding. We are working to put 12,000 acres of flax in production in Pennsylvania. That represents 3,000 or 4,000 acres annually in a 3 or 4 year rotation. And then to establish a sketching mill, a long line sketching mill in the state of Pennsylvania that will process that much flax. This is our team. Is everybody there? And Jeremy. So this is our team and Jeremy. So this is at a harvest event at a very weedy flax field, which is one of the woes of producing flax organically that we are working to solve. But so this is Emma DeLong holding her son Eddie, and next to her is our farmer Jeremy Dunphy, who has generously donated his time and land to help us do research in Pennsylvania. And then Jordan Haddad, our director of value chain, Bill Schick in the middle, our director of agriculture, Janelle Wysock, our director of education, and myself. And thank you, USDA, for making it possible for Pennsylvania Flax Project to have a team. It's incredible. So I just would share our values. And this is really our true north. It's our guiding principles. We are looking to create opportunities for farmers and manufacturers in Pennsylvania and beyond that is responsible growth, both economically and agriculturally. And we're looking to repair and restore nature and human dignity as we do this. And we do hold ourselves to a high standard with that, which is one of the beautiful challenges of stepping into a new industry or an old industry that needs to be reestablished. And we do have a real focus on inclusion. We want everyone at our table. We're doing a lot of research into who our community is geographically and making sure that we reach into our community to include everyone as we move forward. And we envision a textile industry that can create responsible regional economic growth that's good for people and planet. We're on a mission to bring flax for linen production back to Pennsylvania. And we also hope through this activity to support others who are on the same mission across North America so that we can create an interconnected web of regional scale processing facilities and have a sustainable textile infrastructure in North America. And I'll just finish with this lovely graphic of the flax plant, this botanical showing all the different parts. Every part of this plant has a use, and it's super excited it's very exciting to be the continuation of over 30,000 years of collaboration between humanity and this plant. And thank you. I'll pass it on to Alvin now.
Good afternoon and welcome from Saskatoon, Saskatchewan, Canada. My last name is pronounced Ulrich, and lineologist, I made that up. I thought, well, like biologists study biology, geologists study geology. So someone who studies flax obviously is a linologist. Next slide. I guess what you need to know at the moment about me is that I grew up on a farm in Saskatchewan, you know, where there's lots of oilseed flax produced. I'm used to working with large farm machinery on large farm scale farms. And my background also includes economics, agricultural economics. So I did lots of consulting overseas with many different crops and many different agriculture projects in as far as the economic aspects. And one of the things I learned is that if you want to make a change, you know, everyone in the value chain has to be better off, or at least no worse off. And so when I looked at flax research, it's like, how do farmers, how do processors, how do end users, how would they all be better off if we grew more flax for fiber? Next slide. And I started working with a group from Hong Kong who are interested in fiber for textiles. And maybe with that goal in mind, we looked at the highest value fiber that we could make from flax, rather than saying, how do we salvage, you know, say poor flax straw that maybe comes from poorly managed oilseed flax. Over time, Not only did I work with fiber flax and try to make really long fiber, I also worked with oilseed flax. In doing that, we built a processing plant, a small pilot processing plant. We could maybe make 100 or 200 kilos an hour of of fiber, enough that we could send it away to users in different parts of the world and get their reaction to it. And we tried many different things in the field, many different ways to process it, many different ways to ret it and weather it. And from that, we learned a lot. I got involved in most aspects of flax fiber, from working with breeders to, lots of agronomic trials, to processing trials, grading and testing the properties of that fiber and the straw, to end users. So I kind of, from beginning to end, I have experience in all of those things. Next slide. So these are a list of some of the things. One of the things that isn't mentioned here is organoleptic grading. And when I was working on a farm, you often have to make decisions about something, about a crop, or is it going to go for malting for beer? Is it going to be feed barley? Is it going to be, how are you going to harvest and when? And you start doing little quick tests in the field. And in fiber, I worked with developing organic tests for the straw and for the fiber that are very quick and reasonably accurate. They do this in Europe, so I didn't create something totally new. I just adapted what I saw in Europe and just turned it into more of a system where it would be, you turn it into numbers and you could have like different kinds of grades and scores. I've attended lots of flax, international flax meetings, and met lots and lots of flax people around the world. So I'm kind of self-taught in that way, but I think I have one of the biggest knowledges probably of flax fiber and production in North America. Next slide. I've been involved in building and purchasing flax machinery for processing, for working in the field. We also developed an near-infrared system that would, in a few minutes, given a sample, we could estimate the fiber content in it. I've also published a number of articles in journals and popular press relating to flax-on fiber. And I've given both free advice and paid consulting service to different groups interested in producing more flax fiber or using more flax fiber or shives. Here's just a few pictures. Here's some agronomic trials we did, replicated agronomic trials. And note we tried to have broadcast pattern to maximize the amount of consistent and stems that we have in a particular plot. Next slide. These are also, replicated plots. This is harvest. We pulled it, we retted. We looked at retting and, seeding versus retting. We did large scale. This is a large scale field of fiber flax. And you can see I live in a broad acre part of the world where you can have fields that go on for a mile or two. Next slide. We did try European machinery. This is pulling a field of fiber flax. We tried pulling, turning, we tried imitating exactly what Europeans do. We also tried some new methods. So this was fiber flax where we just stripped the seeds off and left it stand over winter and then rolled it in the spring. And so, yes, it's making not long line, but it was making total flax. They call it in Europe total flax, but it's really just tow. You're turning all of the fiber into tow, but you're doing it in a very cheap way to get big volumes of, cheaper fiber. Next slide. So here's an example, of rolling that flax either in the fall or in the spring, and then we would rake it up, let it rake it up. We've also tried just leaving the straw stand over winter where it would get weathered and then cut and bale it in the spring. So we've looked at alternative ways to use existing equipment that farmers have to produce tow. So we don't have to have, expensive, unusual equipment or expensive processing equipment. Can we use it simpler? Some of you may wonder what this is. This is a huge roller. So in our province, people produce a lot of lentils and peas, which often grow close to the ground. And if you have stones, you don't want to pick those stones up into your harvesting machines. So after you plant, you have these big rollers. You can fill them with water or not, and you roll your land and it pushes all the little stones back into the ground. So when you harvest them, you don't grab up the little stones. And it's quite a common piece of equipment, and it actually can work really well to knock flax flat on the ground. Next slide. And we did, here's some fiber market research I did this was in China, and this was an unusual store. It had only linen products on one whole floor, and another floor was just cotton, but they divided their floors by the type of material and not by the user, not by men's wear, women's wear, kids wear. It was like, no, this is the linen floor, there's a wool floor, there's a cotton floor. It's like, oh, okay, that's something different. Next slide. And here's also some unusual uses for tow, and there's lots of it in the building construction. These are a couple you may not have thought of, insoles for shoes because they absorb moisture very well. Seat covers, again, if you've got a hot, humid place and you get sticky on your seat, you can have seat covers out of flax. You can have insulation. You can have various things out of shive as well. And next slide. So if you've got any questions, you can text me, you can phone me, you can email me. I'm available to encourage much more fiber flax production or flax fiber production in North America.
Great, thank you, Alvin. I'll now pass to Marie.
Thank you, and thanks for inviting me. So I'm speaking for the Alliance for European Flax, Linen and Hemp, which is the unique organization that brings together all the players of the flax, linen and the hemp value chain in Europe. It's agro-industrial, from farmers to semi or finished products. That's around 10,000 companies in 16 EU countries. And the Alliance is the reference for any data about European flax and linen, which is a global leader representing 3/4 of the world production of flax fiber. On the next slide, our missions are to inform, support, and promote our ecosystem at large. And that includes providing intel that supports decision making for a tree, but also life cycle data, scientific and technical data, and etc. On the next slide, our ambition is to make European flax, linen, and hemp the preferred premium fibers worldwide. And on the next slide, our strategy relies on 2 certifications of origin and traceability. European flax, which is the guarantee of origin for flax fiber grown in Western Europe, that's France, Belgium, and the Netherlands, and its traceability through global supply chains. And Masters of Linen is for textiles made from European flax fiber, with the spinning and the weaving or knitting performed by European companies on European or Euromed sites. And on the last slide, we support brands with many services, including assistance in sourcing creative and innovative linen textiles and materials through a library, which is in a physical showroom, the Linen Dream Lab in Paris, as well as participating in different trade shows in Europe, as well as a digital platform, linendreamlab.com.
Great. Thank you so much, Marie, and thanks for joining our panel. I know it's late where you are. Okay, great. Thank you. So Heidi, I wonder if you could tell us about your researching how flax can absorb heavy metals from the soil and help to remediate the soil.
It was a sort of accidental research that started in 2021 when we connected with the artists at Zacate Latinx, which is a group in Norristown that does art and after-school programming and gardening. And they were living on a lead contaminated area and wanting to grow food. So they came to a processing workshop of ours, and we were talking to them about how flax has the potential to remove lead from the soil. And they just lit up and they were like, come and try it at our place. And so we did. We gave them seed and we planted a large amount, and they connected us with Dr. Kabindra Shakya at Villanova University, who he and his grad students took on the research as a class project. Thank you. And there were great results. So the flax very effectively pulled lead out of the soil, and we have repeated the study for 3 years now with Villanova. And the next step would be to test the fiber in the plant to see if there is in fact lead in the fiber or not, or and what sort of result that would have. But even if there is lead in the fiber, it is still much easier to grow a plant and then remove the biomass than it is to dig up lead soil, which is the only other way to remediate. So Dr. Kabindra Shakya at Villanova has done a lot of research with urban gardens and soil remediation. And we live in Philadelphia, which is a very heavily lead contaminated city. And a lot of the community gardens cannot grow in ground because of lead contamination. So we're looking at this as a potential application for flax growing. And we've also been in conversation with people who stored brownfields, which are very large contaminated areas, as using flax as a soil remediation.
Yeah, it would be amazing if we knew exactly where it went in the plant and we could do it at scale.
We'll get there.
Yeah. Okay. Hi, Alvin. I wonder if you could tell us a bit more about your research to estimate the flax fiber content in the flax straw, which you've been using to help flax breeders to develop new flax varieties in North America.
Well, flax fiber is somewhat genetically determined. And so we know that if we keep selecting lines of flax or crosses of flax that have higher fiber content, eventually their offspring have higher fiber, and their offspring's offspring. We can raise the fiber content over time by selecting lines that have more fiber. The traditional way to find out the best fiber, you would take the straw, you would wet it, you would dry it, you would extract the fiber. It can take 10 days. With the near-infrared system, we can do it in a few minutes. So you can go through thousands and thousands of samples of, crosses. And in Saskatoon here, where I am, is the major flax breeding center for Canada. And they do literally go through thousands of lines. They make some crosses and you get all this offspring. And you sort them out for, I want something early maturity. I want something that doesn't lodge or doesn't lay down. I want something that has good seed yield, that's disease resistant. Oh, and then you could say, and I want something that's high fiber or low fiber. And so near-infrared lets you go and test the fiber content really quickly. And so you can make progress. Whereas have I told you, well, it's going to take you 10 days to test every line, you go, I think that's something I'm not going to test for. So that's where the near-infrared is very useful, because it speeds up speeds up the whole system, and it's much cheaper. It takes several years to make a good database to do that. So the big cost is just to make up the database. But once you have it, then it can save lots and lots of time.
Great. And you've developed this database over time from your research, is that right?
Yeah, it took us about 4 years, because you have to wait for different kinds of weather, and you want samples from different parts of Western Canada, and you want dry years, you want wet years, you want clay soils, you want sandy soils, so that it's kind of like an AI. AI works better and better as you feed it more and more information. The software has a better and better idea of determining, what's the critical wavelengths that will tell you the fiber content, no matter if it's a dry or wet year, or if it's a sandy or a clay soil. So it just takes years to get a good database. It takes years to build it. Some
Yeah.
people try to build one in 2 weeks with 20 samples. Yeah, that's not very predictive in the long run.
Great. Marie, could you please speak to the importance of traceability and the value behind your two certifications, European Flax and Masters of Linen?
Yes, well, those certifications, they guarantee the raw material origin, which is a challenge for most fibers on the textile market. So in our case, it's a guarantee of a fiber that is grown in Western Europe under responsible practices that run along the principles of integrated crop management. They also guarantee third-party verified traceability through the supply chains. And that's answering key expectations today, and growing expectations, both about environmental and social responsibility. That is key because the brands need more and more to be able to prove their claims. So that enables not only storytelling, but also story proving. In any case, these growing expectations will only be reinforced by the evolution of regulation. And that's probably what explains the huge success of our certifications. For example, European Flax now certifies more than 1,000 textile companies processing European flax. And since 2020, that number was multiplied more than 10 times.
That's amazing. Thank you. Heidi and Marie, I wonder if you could both speak to how beneficial it is for flax to be grown in rotation with other crops. Sure, you can start.
So rotational cropping is beneficial because you have, every crop has a different need from the soil, right? So every crop will draw more of a different nutrient or need more of a different nutrient. And flax is particularly attractive to farmers because it is a very early spring crop, so they can get it in early. It matures in 100 days for fiber. And then there's a readying period, which varies dependent on the weather, but in our region, it's 2 or 3 weeks. So that's like 121 days. So it's a pretty quick crop. They could get it in early and get it out early. And that gives them the opportunity to plant a second crop in the season, or to put in a really nice cover crop that can stand for a long time and then be worked back into the soil or crimped and left into the soil to build up soil health. So we are in North America in the early stages of researching what crops will be best in rotation. And, we're looking to learn a lot from our European partners.
Mm-hmm.
We're looking in Pennsylvania at putting flax into rotation with small grains like oats and wheat and corn, but not planting your flax right after the corn. And so hopefully we'll know a lot more in 2 or 3 years. But flax it's a low nitrogen feeder, so it goes nicely in rotation with things that are higher nitrogen feeders, and it makes you need less inputs for crops as you balance your rotation in that way.
And another benefit of the rotation will be to prevent disease, because typically one type of crop will support the development of the same disease. So alternating the crops also prevents disease from being too much rooted in the soil. And as far as the beneficial effect of flax shows, flax has long roots that leave a good structure of the soil, and also the part of the roots that will remain in the soil after the pulling, they will degrade, and that serves as a fertilizer. And typically, the following crop after flax will have a yield increase of, let's say, 5% on average.
Emery, in Europe, you're typically rotating every 7 years on the same plot of land. Is that right? Right. And
Yeah, exactly.
saying you're going to try 3 to 4.
We're going to start with a 4-year rotation, and
Okay.
as agriculture scales, we'll extend that to the 7-year rotation.
Okay.
Part of that window of time has to do with disease pressure, and because we haven't grown flax in our region in a couple hundred years, we can start with a shorter rotation, which will allow us to scale responsibly and increase that rotation.
Alvin, I wonder if you could talk about the possibility for a dual purpose flax variety grown for both fiber and for oil, where it's possible to achieve high yields of both.
It depends a lot what you want the fiber for. You know, if you want the fiber for very fine textiles where you have very fine yarns, then you want to harvest the flax when it's still immature and the fiber is not totally filled with cellulose. And when it's, so if you're going to harvest it immature, you're not going to get much seed yield. But there's a growing use for, or many growing uses for flax fiber that's a little, a little fatter, a little stiffer. So if you were making coarser textiles, or you're making insulation, or you're making filters or geotextiles where you want a little bit coarser yarns, or you can live with a little coarser yarns, then you can have, you could breed for higher seed yield and higher fiber yield. So it depends a lot on the intent that you have for that fiber. But they're both, I could see it certainly a place for a dual purpose flax and the possibility of breeding one. And there's certainly lots of new things in the world of new ways to genetically modify flax as well to create something that's beneficial in many ways. So yes, I think there is a possibility, but again, if you want really fine fiber for the finest kind of textiles, probably not, because you're going to probably still have to harvest it when it's really young.
Marie and Alvin, the flax tow, the short fiber, is often used for composites, but they're often still combined with synthetic epoxy resin binders. So I wonder if you could speak to how realistic it is for us to get these high-performing composites, but that could also be biodegradable eventually and using bio-based binders.
Well, first, maybe I'd like to go to the main uses for the flax short fiber, which are textiles, actually. The flax short fibers are typically used in carding and combing processes, which are a bit similar to wool, and then dry spinning, allowing for bigger yarn counts. For heavy fabrics like upholstery, for instance. The flax short fiber, also called tow, can also be cottonized, so cut and refined to be blended and spun in cotton systems. So these are really the main uses for the flax fruit fiber. But they can also be used for composite materials. Then the choice of the resin that will depend on the final product and the performance that is required. If you're making a boat or a surfboard or a helmet for biking or for riding, for instance, then you will resort to synthetic resins. But if you're looking at design applications, like acoustic panels, for instance, that can be made from bio-based resins.
I would just add that there's more and more research into bioresins because, there's a worldwide demand for having greener resins. And if we looked at 20 years ago, there was maybe only 1 or 2 bio-based resins. I think now that, there's dozens and dozens of bio-based resins now, and they are getting better and better, and chemists and chemical researchers kind of see it as a challenge is now to replace a lot of those synthetic resins with bio-based ones. And so I think the future is quite positive that we'll see more and more and better and cheaper bioresins in the future.
Great. I hope so. Yeah. Marie, I wonder if you could also talk to us a bit about how can we transition the industry, which is so dependent on polyester and these synthetic fibers right now, to diversify their material choices to adopt flax and hemp as fiber choices.
Well, first, let's remain humble because although the flax surfaces in Western Europe were multiplied by 2 over the last 10 years, we remain a niche market that represents less than 0.5% of fibers worldwide. But for sure, we play our part in the transition of the textile industry through clear commitments and tools that support decision making. It's very important, I think, to enable reliable claims. And there are new regulations. I'm not very familiar with US regulations. I could talk more about European regulations, but there are several directives under the Green Deal that fight greenwashing. So any claim, any marketing claim has to be backed by scientific evidence. And in general, compliance is more and more required. So let's say that the brands are increasingly committed to this compliance, and they don't have a choice, I would say. Directives such as the European Eco-Design Directive that will make the digital product passport compulsory, or the Corporate Sustainability Reporting Directive. These are very, very strong incentives. And as the flax linen sector, it's one of our missions to make sure that they have answers and data to build their strategies on.
Heidi, do you want to add anything to that?
I just think we have a really strong educational component to our project, and that it's really came from the place of that most people that I speak to in North America really don't know that linen comes from flax. And I think that to encourage people to turn to a product, they have to understand where that product came from. So I liken it a little bit to the food movement in the US, where, 20 years ago, people thought all carrots came from the grocery store. And there was a huge educational push to teach children and intergenerationally that carrots come from the ground. And that has been a very successful marketing campaign. So in our small way, we're starting that marketing campaign in our corner and hoping that it catches fire.
Yeah, I connect to that so much because I think that's part of the inspiration for this exhibition for me as well, because just designers who study textiles maybe never see like where the fiber is coming from. They're like starting at the design process without seeing that full life cycle of the material. So like helping to educate the designer from the ground, from the agricultural processes that go into the fiber is so important.
And there's a real joy in it as well. So
Yeah. Um, okay, great. And Heidi, I wonder, could you talk a little bit about organic agricultural practices? I think you've kind of said that you're low till and low pesticide, and what does that mean exactly for our audience?
yes, this is where I wish my director of agriculture were here, but he's not. So I would hesitate to say that we're low till. And I would start by saying that, organic practices and no-till aren't always a happy pair. One of the ways that no-till farmers control weed pressure is with a lot of herbicide. So in organic production, there is generally some tilling that happens. Some crops need more than others. A diversified vegetable farm can get away with very little tillage because you could sort of have a lot of weeds and still get a good harvest of your tomatoes. That's really not as true with flax. You need your flax crop to be clean going into the mill so that you don't have a lot of weed contaminant in the resulting material. So we are supporting anyone who wants to grow flax in North America, and we're working to like learn how to scale this agriculturally. We're particularly focused on organic production, but the amount of bed prep that's required both before planting and after harvest for flax is not unusual in organic production, but I'm not sure that it's definitely not no-till. So I just want to, that's a very complicated conversation about tilling and not tilling, organic versus non-organic, and quote, regenerative farming. So I would say that flax has a relatively shallow root system that's pulled. So when you pull it to harvest, you're sort of disrupting the first few inches of the ground, and that leaves a clean bed for your retting, which you need so that you don't have a lot of weeds in your retted flax. And it also leaves a clean bed for the crop that follows it. So that's beneficial in organic production. Organic flax, like any other agricultural product, is much more difficult. I believe it's 1% of production. So we're looking to increase that. We're doing a lot of research around it.
Yeah.
Complicated conversation.
Yes, maybe I could add that as Heidi said, flax is a low input crop, doesn't need a lot of fertilizer. In fact, doesn't like having much fertilizer because it can represent a risk. Well, in Europe, we follow principles of integrated crop management, and the use of pesticides are reasoned depending on the situation. So generally, we can say it's a very responsible crop. There is some organic cultivation, certified organic flax, but in Europe it represents more or less 0.3% of flax surfaces. So more or less the same figures as you were quoting.
So hopefully we'll see more organic flax at some point.
But as flax is grown in a long rotation, the development of organic flax is also limited or conditioned by also the switching to organic outlets for all the other crops of the farm.
That's a really important point. in Pennsylvania, we have a small number of organic grain farmers, right? So when you put a crop in that you're going to put in every 7 years, everything else on your farm has to be organic in order for that crop to be certified organic. So
Oh, wow.
you do have to find people who are already farming organically. It's a heavy lift to get a conventional farm to transition to organic for flax,
Mhm.
right? And of course, we're just taking on that heavy lift with the organic market development grant. So we are, if there's any Pennsylvania farmers out there who are already organically growing small grains, we'd like to add flax into your rotation.
Oh, wow, I didn't realize that. But yeah, that's a great point. And Alvin, I wonder, could you speak with some of the challenges you've had in scaling short fiber tow production?
Yes. One of the problems, of course, is if you want better tow production, you want farmers to do not a lot of things different, but somewhat different. For example, we'd like to keep the straw as long as possible. We'd like to have the straw either retted or weathered so that you could easily get the fiber out of the straw, and then you have to, of course, pay them extra to do that, and which comes first, the processing plant or the improved ways to grow flax. And so you say, well, we should have a processing plant. So then you look at the investors. Local investors here know basically nothing about fiber markets. And for them, people don't use fiber anymore. Fiber comes from Asia. It's just they have no context about fiber industries here in Western Canada. So that's a problem. We get sometimes foreigners that come here and they're from, fiber intensive countries like China or India or, or Europe, and they look at the potential here, but they have no knowledge of, local agricultural practices and the local weather. And so they don't really want to invest because they're not familiar with how we would do it, because they don't see it exactly the same as what you would do in Europe, for example, or in China. So foreign investors don't know local conditions, and local investors aren't really familiar with, world fiber demand. Another problem is the scale. So given the wages that people expect in North America, you can't be making 5 kilos an hour in your plant. You've got to be making, probably at least 3 tons of straw an hour. You have to be processing to pay people the kind of wages they need. So then you need to have lots of equipment that makes that labor very productive. And that means you need to kind of get scaled up. And we've also had, buyers that love our fiber that we produce in our tow facility or a pilot facility, but they say, I love this, but I need you to guarantee at least 80 tons a month, every month for the next 24 months or nothing, or I need 200 tons a month for 18 months, every month. So you go, well, that's such a big volume hurdle to start with. So those are some of the obstacles is, how do you, because you're not going to be big right away. How can you scale up in a smaller way? And whether it's tow or long line, you have the same problems. You can buy this, several $1 million tow processing or long line processing plant. And then you go, yes, but I have only 100 tons this year. Oh, so that is going to be very, very expensive to process. So, either you have deep pockets and you can finance it for some years until you get to be a bigger volume, or maybe you can pay people, 10 cents an hour, or they're all volunteers. But it's a challenge starting this kind of an industry from scratch when the quantity hurdles are quite high. It's not impossible. It's just a big challenge.
Yeah, I think my next question for you relates to this quite a lot as well.
I'd say, amen, Alvin. The truth.
Heidi's team really has this goal of creating this scutching mill in North America for processing longline fiber. But you would need 3,000 acres of flax to support it. So could you tell us a little bit more about how you're going to achieve this goal and
Sure.
when do you think?
And when, she
Yes.
says. Yeah, so I would say we need between 3,000 and 5,000 acres of in production annually to support the size of mill that we're looking at and to pay the size of team that we're looking at, the amount that we need to pay them. It is no small feat to achieve that. The short answer is we're going to achieve it methodically. When Emma and I started in 2020, we decided from the get-go that we were not going to be in a hurry. We were going to very methodically learn as much as we could and make sure that we had a solid business plan before we took wild leaps. And the issue is that you have to build all 4 legs of the table at the same time while you're eating off it. So it's a timing issue of scaling the agriculture whilst creating the built environment strategy and fundraising for the mill so that your agricultural stage doesn't outrun the implementation of a mill. And I have spent an enormous amount of time in the past 6 or 7 months since we received funding, looking for more funding to guarantee minimum payments for our farmers so that I can ask farmers to take a risk on this niche crop that they're not familiar with. And so that's the game. You know, you spin the plates and you put the attention into the segment of the industry that needs the most attention at the moment, and you build all the legs of the table.
And you're building this out as a co-op, is that right?
We're building it out as a co-op, yeah. So when we have early adopter farmers who are interested in the cooperative model, it's beneficial for farmers in particular because like the American model of commodity crops is that the farmer grows the crop and then the processor pays the least amount possible for the crop. And then that's it for the farmer. And in our model, the farmers will also be owners of the mill. So we'll be a worker-owned cooperative, a producer-owned cooperative. And so farmers can realize profit at the level of the mill. Yeah, so we're doing that. It's a little bit, it's a lot. When is a good question. Like our really ambitious goal would be to say that we would hope to bring a mill online in Q1 of 2027. There's a lot that has to happen between now and then. So hopefully we'll be back and talking about the mill at that point. We'll see.
Yeah, I hope so. That's great. And Marie, I think going off of this, so once the material is at scale, you know, the linen is so much time, it takes a lot of time to process and is very labor intensive. So I wonder if you could talk about, are there innovations looking at to simplify the processing steps? Could you speak about how to reduce the cost of linen itself?
Well, flax linen processing steps are very specific and require a lot of expertise. I don't really expect that to change much. If you take, for example, the spinning of flax long fiber, the first step, preparation, that consists in blending usually 20 plus different batches of fiber in order to produce a yarn that is that has optimal quality and consistency over time. In fact, I think that linen is becoming increasingly recognized as a fiber of excellence, and it should be recognized as a fiber of high value, and rather than trying to fit it into lower value processing. If you think about luxury or affordable luxury collections, when we talk to brands, we see that the share of linen in their collection is increasing. If you think about high-end interior fabrics collections, or in fashion, for instance, Zegna's Oasi di Lino collections that have made linen a real protagonist, or Loro Piana's presentation during the Milan Fashion Week in September. That really, I think, matches the kind of positioning where linen should be.
And Marie, could you also speak to how flax can be zero waste when it's at scale?
Well, it is actually, it is zero waste. During scotching, when the fibers and co-products are extracted, you get, so of course, the long fiber, which is what is the real, let's say, benefit for the farmer. And the long fiber would make more or less, in average, 20 to 25% of the total weight of the straw. So obviously the long fibers are used for textiles or composite applications. The short fiber would be between 10 and 15%. So as I said, they have a lot of different uses in textiles, as well as other outlets. And then there's the chives, the woody parts of the straw that represent more or less 50% of the weight of the plant. And that is used generally for gardening chive or animal bedding, or can be used. We are looking also at ways to burn them to recover energy. Then there's the seeds, which is more or less 5% of the weight. And so as I'm talking about fiber flax, seeds is not the main goal of cultivation, but of course they are used. They can be then used for sewing again, or they can be pressed for oil and fed to animals, for instance. And then remains some soil, dust, and etc. But even that is used, and generally that's used for compost.
Alvin, I wonder if you could also speak to how flax biomass is used in different construction products, and how do you see the industry better utilizing flax straw that is burned for byproducts, and what are the barriers to that?
People burn it. I mean, there's still here oilseed flax is still often burnt because it doesn't. It has enough fiber in it that it's very hard to work into the soil before the next spring, or it's chopped and spread. But it certainly could be used for lots of construction products. We have insulation. I think in Europe there's 6 or 8 companies that make wall and ceiling insulation with fiber, flax fiber bats, and they're using shorter fibers or fibers that are just definitely not good for textiles, but they still make wonderful insulation. They can also use them in flaxcrete, which is like hempcrete. Again, it's the shorter, rougher fibers and some chives, depending on the recipe that you're using for flaxcrete. And it makes concrete that's, concrete blocks, for example, or walls that are much lighter weight and absorb sound better and insulate and keep the heat in better. They're not good for weight bearing, but they're great for, the side walls. And for the vast majority of walls that you have, flaxcrete would be, is a good substitute. They're also putting them in concrete floors for strengthening as well. Filters, which is kind of a construction product as well, ceiling tiles, even some kinds of wallpaper and wall finishes, some really short fibers used in stuccoing on the inside or outside as well. So those are some of the examples of construction uses, and there's more and more uses coming up. If there was more supply, people would find more uses for them in the construction industry.
We actually did some tests of Flaxcrete, which we call Flax Lime, for the exhibition. So for anyone who's here in person, you can see them when you come to visit.
And for using it, if farmers, the longer the straw is and the more intact the straw is, the more even the pieces of straw, the more even the fiber will be, and the more retted or weathered the straw is, the easier it is to get fibers out. So it's a combination of, improving the straw so you get better fiber, and so you make it more suitable for construction. And again, people want it, a big enough volume so that it's worthwhile to do, let's say, building test. If it has to meet certain performance standards, before you do all the testing, you want to make sure that you can get enough volume every year to make your testing worthwhile.
And maybe may I add another use that is, I'm not sure it's the proper word, but as an underlayer under wooden floors, that's also used for that.
Great. And just one more question before I open it up to the audience questions. Maria, I wonder if you could talk about how you're breeding the flax crop to adapt to climate change.
Yes, well, there's a lot of agronomic R&D supported by our agronomic institutes in France and Belgium. They are researching new varieties that are more resistant to stress, water stress and temperature stress. And they're also researching winter flax varieties, which have a specific cultivation calendar. So winter flax is sown in the autumn and then harvested in the summer when spring flax, well, is obviously from spring to summer. So there's just a short difference, maybe 1 month's difference between the harvesting times. So the winter flax shows interesting potential, well, different performances, but different risks as well. So it's a way to, let's say, spread the risk. It offers more opportunities, diversification, let's say, for the flax grower.
Okay, great. Please speak into a mic if you're asking a question so everyone online can hear.
Just raise your hand.
I see the chat, the question and answer, there's quite a few, people have written questions, excellent questions in the chat box or in the Q&A box.
Yeah, we see them, Alvin. And what we've done is we've ranked them by the number of, likes they've achieved. So Claire has a great question, I think, for Heidi about your lead remediation work. And she asks, when using flax to remove heavy metal, can the fibers be used in clothing textiles? Are the seeds good for planting or eating? Or are those fibers and seeds garbage? Yeah.
Right, all questions we haven't answered yet. So I say we don't know. This is the next step of our research. So we hopefully this year we'll be looking at where the lead actually goes into the plant and where it's stored. The hope is that it won't be stored in every part of the plant. That's not generally the pattern. So the hope is that we'll get some useful part of the plant that doesn't have any contamination. One of the things I'm really fond of saying is that at least it's not polyester, right? So to find out if it's toxic, really. Yeah, so we don't know.
Do you have current funding for that research? Is that-
We're working with universities, and so
Great.
right now it's embedded in their programming. So it's not our independent research. They're really doing it within their programs.
So stay tuned for that important research.
Stay tuned. Yeah.
Yeah, sounds great. Rosie has a question for Alvin. Where can we find your research online, Alvin?
Where, I guess if you search my name, you'll find some things in ASTM. Some things are, are published locally, only locally, for, research projects that we carried out. And some were published, in journals or in the popular press. And some weren't published. So it's a combination, you can email me directly, and tell me what you're specifically interested in, but you can start by just, doing a Google search with my name.
Great. So that's for you, Sarah. Google Alvin. That would be good. Yeah, and I just wanted to share something of Martha's. Martha says it's not really a question, but you could respond to it. But there's so many regional and local economic benefits to regional natural fiber cultivation. This is what we say a lot too. The jobs are created, which are not the case for imported fossil fuel fibers. There are greater opportunities for collaboration and innovation with academic and research institutes, and it brings greater economic resilience. So I don't know if each of you would like to respond to that, that is one of the more systemic benefits of working in this space. Marie, maybe would you like to, because it seems like, the foundation of the network that you've created really kind of speaks to the importance of working together and then the impact of all of those companies working.
Yes, well, we see that this is really an ecosystem that is interconnected. There are obvious interconnections, for instance, between the flax grower and the scotcher. This is a duo that makes all important decisions together. Between the scotchers and the spinners, because the selection of raw materials will be crucial to achieving optimal yarn quality. Between spinners and knitters, for instance, for a long time it was viewed as a nearly impossible challenge to knit linen, because linen is somewhat irregular, is not very elastic, but by collaboration between spinners and knitters, that was achieved. And now, yeah, I think linen jersey is one of the mainstream materials. So that's we see examples of this collaboration at every step. And for our European flax linen sector, our yearly get-together, which is called the forum of the Alliance, that's really a key moment where we can see each of these important links in the chain supporting each other, even through difficulties and crises. And overall, it's we see the social value also as being recognized more and more. And typically, flax linen brings employment in rural areas that is much contributes a lot to the social well-being in these areas.
Great.
I could give you a quick example. Some years ago, I visited France, and there was I think two brothers were farmers. Anyway, they sold their farm and started a flax fiber processing plant. They contracted about 10,000 acres a year. They turned it into long line, into tow, into chives, and into a little bit of seed. They had 120 people working for them, and whose salaries were more than in Canada in the rural area. They had about $25 million of sales at that time, and this is maybe 20 years ago already. In comparison, 10,000 acres of oilseed flax, where the seed is just exported, would probably create 4 months of a job for one person. The hauling of the grain to the elevator agent, the train carrying it to the terminal, a little bit of cleaning in the terminal. It's a huge difference, a quarter of a person year on 10,000 acres versus, 80 to 120 people working full time for that same amount of area of land. It's like, oh, that's a huge difference.
Heidi?
Yeah, I would say it's really interesting for us to experience sort of bringing together all the different portions of the supply chain, the textile supply chain in Pennsylvania. We have a remnants of a once very thriving textile industry in our region. And so to see that reintroducing this from seed to spinnable fiber piece of a supply chain, you start to engage with folks who want to then figure out how to spin it, people who are already spinning wool and cotton who are interested in using short fibers, weavers who still can weave the bast fibers who are excited. And so I think there's really in hubs like this in North America to reestablish not just the portion of the supply chain that we're focused on, but to work toward achieving what Marie speaks about, which is something that is really integrated into a culture throughout the whole supply chain. And I'll say we were recently in Europe, and the thing that I was really struck by is how embedded in the culture flax is there, and it's very inspiring.
That's great. Anybody in the audience who has thought of a question in the meantime? Or should I keep going? No? Okay, keep going. There are some questions about rotation, but I think you covered those, right? Really? Yeah, I'm interested in this. So this is a personal question. When you talked about really the circularity and use of the entire flax plant, I'm wondering, they're asking about what happens with the oil seed flax plant waste. If there's different characteristics, I'm assuming, with an oil seed plant as opposed to one grown for fiber. But are they similar to what's happening with a flax plant grown for fiber?
They're pretty much the same. The chive, the fiber content, the cellulose, the lignin, it's pretty much the same. It's just fiber varieties, fiber varieties have about roughly, like, say 30% fiber. Oilseed flax has maybe roughly 20% fiber. Oilseed flax has maybe roughly 3 times the seed yield of a fiber flax variety. Otherwise, you get the same. You get chives, you get, seed ball holders, you get, the covering of the seed, you get the roots. They're pretty much the same. Only here with oilseed flax, it's basically chopped and rotted and turned back to the soil, or it could be burned.
This is a question specifically, you've talked about the history of growing flax in North America. So is there a native species of flax? I know people always ask this about hemp. If there's one in North America and Pennsylvania, why was cultivation stopped in Pennsylvania? And what are, if any, indigenous practices and culture around it? It's such a great question for us in North America, where we stopped growing flax, I think. And often, when people, I'm speaking for architects who are interested in, suddenly interested in plants, they imagine that time starts now, rather than there being a whole historical series of events and precedent for what we're doing. So really kind of understanding a little bit more about that history in North America.
There's 3 kinds of there's three kinds of wild flax that grow in North America. There's, maybe another 20 species of flax that grow around the world. One of those, is Linum utilizaceum, the kind that we use for both fiber flax and oilseed flax. And that was introduced into North America by, the early French and English settlers that came. So there was no indigenous flax that was used for fiber. There was other fiber crops like dogbane or Indian hemp or milkweed or nettles that were native that were used for fiber, but flax was not. There's native flax, but it has very, very low fiber content. And so anything that was used for fiber was from an introduced kind of flax.
Heidi, you wanted to say something? Yeah.
In Pennsylvania, in the 1690s, flaxseed was brought to Germantown by the Dutch settlers who settled there. 4 of the original colonizing families were in the linen trade. So we do acknowledge that flax cultivation in Pennsylvania has a colonial history. And as we look to reimagine that industry, we're looking to not replicate the ways of the colonizers. So that's part of our commitment to inclusion in our projects. So flax cultivation in the eastern United States really stopped in the 1800s, in the mid to late 1800s. And that was shortly after the advent of the cotton gin, where cotton had the advantage of this early mechanization and also the, I guess you could call it economic benefit of the labor of enslaved people. It won the economic race here on the East Coast, and flax really stayed more like a farm-based, family-based production. In Pennsylvania also, farmers grew fiber flax seed and exported it back to Scotland and Ireland, where they then grew the fiber flax and then sold us the yarns. So possibly not the best business model, but that's what happened. So production actually on the west coast of the United States was still happening up until the 60s. Like out, I think in Oregon, the last sketching mill that closed in like 1960 or thereabouts. And that I think survived through military contracts. And so it was after the Korean War that sort of fell apart. And the industry as a whole took a hit, I think probably globally, with advent of polyesters and whatnot after the Second World War, when chemical companies pivoted into textile production.
There was also several flax mills in Quebec until the 1960s or middle 1950s, and then it died. But, for more than 400 years, linen was grown and produced in Quebec.
I wonder, Jess, if there's any final comments. What do you think as we close?
Any final questions or anything?
Yeah, I think, there are a few questions, but I wonder if the panelists have any final thoughts before we close.
Yeah, anything we missed that you would like to touch on before we close?
Nothing I can think of. I would just, my final comment would be that it's really an honor to be on a panel with these esteemed colleagues. So thank you for inviting us. And it's a really exciting time for linen in North America. And I think hopefully globally, hopefully as people turn to more sustainable resources, the flax plant has a lot to offer across a lot of different industries. So I'm optimistic.
Alvin, anything you want to add?
I could just add, I know one of the questions was something about wrinkling, but linen still wrinkles. I have there's new ways to get rid of the wrinkles. There's treatments like you have for cotton that, really reduce the wrinkling of cotton. Those similar chemicals are available for linen now. There's also the possibility of knitting linen. So what I'm wearing today is a linen polyester blend, but it has a high % of linen, and it's knitted, doesn't wrinkle. It's really easy to care for, and it is the coolest thing, physically the coolest thing that I've ever worn. Even cooler than a cotton t-shirt.
Jess
And
is
you have
going,
to put a little bit of synthetic, either spandex or a little bit of polyester to give it a little bit of give during the knitting process.
I think Jess is going to give you a response to applying any finish to linen that will stop it
Yeah.
wrinkling.
Yeah, we like wrinkles. We're okay with the wrinkles. We have to accept the quality of the fiber, I think, a little.
Rather than add formaldehyde or some
Yeah.
other nasty thing.
No
Well,
chemical.
I like wrinkles too. I mean, it's character lines in every fabric, every garment has a different pattern of wrinkles, but not everybody has that same view.
But actually, Alvin, you can knit pure linen. I'm actually wearing pure linen t-shirt knitted and the sweater as well. So that works very nicely, even without polyester.
That's fantastic to hear. Yes.
And other maybe useful tips would be, well, some diagonal widths are always better to decrease the creasing compared to a plain weave. Also using crepe yarns that improve the drape or the fluidity. Some blends with the responsible viscose, lyocell, tencel, etc. That could be also some nice ideas.
Any closing thoughts, Marie, as well?
Well, thank you very much for inviting me again. And well, I look forward to seeing the photos of the exhibition because obviously I will not be able to come in person.
Thank you all so much for joining us. It's such an honor to have the three of you on our panel. Thank you again to our sponsors, Forbo, Duracle, and Tuscarora Mills. And thank you to all of the groups who are exhibiting with us, all the people that have donated to our exhibition. Thank you so much. And we hope everyone will be able to come and see the exhibition before it closes on November 12th. Thank you.
Thank you.
For those of us that can't go in person, is there a good way to, kind of view the exhibit?
We will have video and photos on our Instagram and our website, Healthy Materials Lab, if you want to check us out.
Okay, good.
Great. Thank you so much.